Okay, we've got a vector ratios question here. Part A and B you'll find are quite straightforward, but part C involves this idea of vector ratios, so we'll have a look at that in slightly more detail. Let's have a go. Our first mission is to find AB, so the journey down here, A to B. Right, well, we've got to travel along known vectors to find the result. So if we travel the wrong way along vector OA and then the right way along vector OB, that will be the same as the vector AB. So I can say the vector AB equals, yes, our first journey down here, but because we're going the wrong way against the vector 3A, this will be negative 3A, and then plus, because we're going to be going the right way along vector OB, plus 4B. And that's the first answer. Okay, part B. We're asked to find the vector OC. Now, how can we travel OC along vectors we know? Well, again, it's quite simply, we travel along OB positively, and we actually travel along BC positively as well. So OC is equal to 4B plus 2A minus 2B, and that will simplify to 2A plus 2B, and that's the answer to part B. So let's now have a look at part C. We've got to find the vector ratio of AP to the complete line AB. Now we know AB because we've worked it out in part A. So AP must be some sort of proportion of AB. So the first thing I can say is that AP, which is this vector here, must be equal to a proportion of the line AB, which is minus 3A plus 4B. And I've introduced this constant k to reflect that. So this k will turn out to be below 1. It's an amount of the complete vector AB. And as you can see, I've popped our result on the diagram. I've now got to do a journey that involves our result, and that clearly will involve k. If I do the journey OP, I can go up OA and then down the vector we've just found. So I can say that OP must be equal to 3A plus the result we've just found, which is k, negative 3A plus 4B. It's usually quite beneficial to group the A vector and the B vector together. So in other words, we will multiply this bracket out. So this is equal to, in A terms, we've got 3 and then negative 3k. That's our vector A component. And the B component is the multiplication of 4b and k. So this will be 4kb. Now here comes the clever bit. OP that we've just found is part of the line OC. It is collinear with that line. It has the same gradient as OC. Now OC, which is here, has equal components of the A vector and the B vector. So it must mean that our result also must have equal components. In other words, 3 minus 3k must equal 4k. So let me write that result down. Therefore, I can say that 3 minus 3k must equal 4k. So if I move the 3k onto the right-hand side, it becomes positive. So I can say that 3 must equal 7k, and therefore k is equal to 3 over 7. And that means that AP is 3/7 of the journey of AB. And that also means that PB is 4/7 of AB. So in terms of ratios, the vector ratio of AP, our smaller distance to AB, the whole thing, will be 3 to 7. Incidentally, if you wanted the ratio of AP to PB, the other bit of the line, this would be the ratio of 3 to 4. because this will be 3/7 and 4/7 of the line. And there you have it.